Okay, so first week, what was the main, like, basically in the first week, what we did, like, somebody recollects?
First week we did about data sets.
Okay. No. Fifth week, sorry.
Fifth.
Okay, so week 5.
Yeah.
So it was about speaker diarization.
Speaker derivation, I think it was in the sixth week, if I'm not wrong.
Oh, sorry, it was about identification, introduction to language identification.
Yes. So, so he started with this again. We load this data. So loading data, we know how to do it. So there is no issue in that. So this we understand again, streaming is to true, so that one by one, and we are loading only the in. So data set will be the data set type. है ना?
Hmm.
Okay, then we go to next step. He did. Then he's taking the subsets again of that. Okay. So this we understand again, subset again from the enumerate data set, and we are taking I greater than equal to 200 break. So we are taking only the first 200 sample points from this. Then we come to the next one. Then he did for the same steps again he did for the other language. And on the same concept, we had the GA also, na? Where we did Tamil and all that. So I'm just copying it here. And then we'll run one by one. Then it is done for Romanian. So now we have got a data set of 600 samples, 200 from each language, na?
Hmm.
Yes.
Okay. Okay. Now we can go to the next one. Yes, first okay, I should. It is loading. And then when we see the length, okay, there is no problem. We see one subset of 0. So these are the things, okay, which are available in this data. Then 201. And what he did again, then we have to shuffle again so that all the languages are equally distributed in the data set. So this is the command again we use shuffle. And this is the main code now. So let's see how much it is loaded. It is loaded, yes. Okay. So now first we understand the subset, what is there. So in the subset, basically, this is a dictionary. We have got audio, LD, language. Then we have got another dictionary, audio. And this audio is still when it is audio has got path, audio has got an array. So this is the one which we have to encode. Then we have got sampling rate 16,000. What is the meaning of sampling rate? It is 16,000 samples per second. Is that correct? Okay, that understanding? Then we have got the raw text of this. We have got normalized text, gender, speaker ID is code transcript, extent. So we have to understand now this code, what this code is doing. This is visible to all of you?
Yes, it is visible.
Okay, so what we have done, we have imported wave 2 VAC2 processor, wave 2 VAC2 model, TQDM is for that. Okay. So processor, we from web to base 960H, okay, we have done. We have also defined the model. So when we directly use the processor, so always remember the processor will have both tokenizer and feature extractor. Okay.
Hmm.
And otherwise, we can use feature extractor and tokenizer separately also. For that, we'll have to import that. So now what we are doing, we are extracting a web to web features from a batch. So, and from where we will do this, we will do from here. Okay. Is this okay? Is this okay?
Yes.
Okay. So we are processor batch audio array. We pass the sampling rate here. We pass a return tensors as PT. Padding is equal to true, and then we pass it to the model. So these are the inputs. We pass it to the model, and we get the features. Okay. So in the first part, what it has done, it has used like a both tokenizer and feature extractor. Then it is passed like a to this model, wave to vector model, which is a CNN based model. And that's how by batch, it has taken the features. I hope this, my understanding is correct, okay? Or we can check this, what it is doing. So see, this is visible to all of you, this one.
Yes.
So we have loaded the processor, we have loaded the model. Now in this function extract where to vec, the processor is extracting the waveform from the batch from array, and it is converting it into tensors using the processor. Now this passes the process input through the web to vec2 model without updating gradients, and extract the hidden state representation, the audio features. And then we take the mean and we convert it to numpy feature. And then it is returning what it is returning. It is returning the features, and along with it is returning the label. So we can see that here. So see, it has passed, it has got the features. So it is passing the features and along with the label, like a language. So we have got the numpy array. It is converted into array. Padding is equal to true. Yes, here numpy it is converting, and then it is a language. So it will be a dictionary. We can see here. Okay. Now we see the next part. So he has done, for example, now using this, it will extract features for all the samples in this. So this will take some time. So it will return a dictionary with the features as numpy arrays and with the label. In the meantime, we see the other part of the code. And now what we will do, we do the train test here. We do. So this is a standard function which we have to do in all the, oh, sorry. So let's understand this part also. So what we are doing the split of this subset which we have extracted. So it will give us train data and test data. And again, train data we are splitting in 90% and 10% as a train data and well data. So we have got three. And now we are preparing data. So we are extracting the features from the uh, dictionary which we have got, and we are separating the labels. So we have got a feature in the tensor format, and we have got the labels in the tensor format. And we pass this train features, train labels, well features, well labels, test feature, test labels to get this. So this is preparation, and after this, if I'm not wrong, we will use a data correlator function. Okay, now we are defining a CNN model. This is our CNN model. So CNN model, what we have defined, we have defined the first convolution layer. We have got input dimension, output channels, kernel size we have given, padding we have given, then second convolutional, then fully connected layer 1 and fully connected layer 2. And what we are getting the output, we are getting the output from fully connected 2. The size is 128, and we are getting the output from that. Is this okay? This part okay? Convolution layer okay? Output. And then we part input length is the train feature shape 1. This will become our input length. Labels we have mapped okay, like these are the three languages. So we are mapping 6 to 0, 0 to 1, and 3 to 2. And by using the lambda, we have done the labeling. And then unit train labels we have found unit 1, unit well labels. Then we have initialized the CNN model. We have initialized the loss, that is cross entropy loss. Optimizer, we have defined Adam. And then we have done a normal CNN model training. So here in this, okay, we have not used the transformer, but transformer we are using in what, okay, to extract the features for web to back. Is this clear, okay? Everyone? Dinkar?
Yes, sir, it's clear.
Yeah. And now, once we have trained this, now we can find the accuracy score on the test data, test and well data, whether it is predicting correct or not. So this was our part of the week 5. So week 5, what are the main takeaways? Okay? Anyone can summarize, okay? Takeaways? We are extracting the features using the word2vec processor, and then we are passing through the model. So word2 जो processor है, it is extracting the raw audio from the array in this function here. So it has got two parts. First of all, it is calling the processor. It returns all those okay, in the tensor form, and then we give it to the model. Model extract the features, and then we get the dictionary with the features and the label. And then features and labels we have got. Then we make train test split data. Then we extract features and labels separately, and that also we return as tensors. So now we have got train features, train labels, all of them, they are in the tensor format. And then we define a CNN model. And in the CNN model, we have got two convolutional layers and two fully connected layers. So from the first convolutional layer, we have got a ReLU function. Then we part to max pool. Then again to second one ReLU. Then again max pool. Then we will do this x dot view, pass through ReLU, and then we pass through FC2 to get the final output. And the input length will be the train features shape 1. Label mapping we have done. We have passed this label, and then we have initialized this model. Loss is the cross entropy loss. Optimizer is Adam, and we pass it through the model train. Optimizer, this is the standard forward neural network steps, and this is how this is getting trained. And once it gets trained, then we test it on our test features. So from test features, we are getting test outputs and squeeze one in the float format, and then we get the check the accuracy. So this looks easy. Okay? Any question in this week 5 वाला question में?
No, sir, no questions.
Okay. So then we go with the hi Vivek. How are you?
Hi, very well. Thank you, Lalit.
So now shall we start with the week 6 also? Week 6, I think it was a derivation. Derivation means that we have got speakers and we have got a speech, and now we have to make out which part has been spoken by which speaker. That was a basic theme of this. And in that again, we use whisper. So let's take this also there in the same collab, or we open a new collab. So already I've got the week 6 wala, I have got this collab file is there. So straight away I can run this. It has got the GA part also, and it has got this part also. So let's go on top. So first we do this, install all this. So first part was to convert the time. So that time we have done. And this second part which is there, this is a very important part. Function to transcribe the audio using faster whisper. So we have written a function. Our audio file model name is base, language is English, beam size 5, best of is 5. Model whisper model name, compute type is int 8. And from here, what we are deriving the segments. So model transcribe audio file, beam size, best of this, language is equal to language. And it will give us the segments. And now transcription will give start and end. So it will give the segment start, it will give segment end, and text, the segment dot text or segment in segment. So it will return this transcription. Let's see how it will work.
Sir, what is this beam size?
Beam size, you remember that we used to do out of 5, like we can select one by one. So it is not, it will do randomly. Okay, it will not always give the same output. Okay, in LLM we were taught, you remember week 7 or week 8? This was taught to
Actually, I
us.
haven't done that.
Okay, so to bring the randomness, basically you have got this beam size.
It's the same as in AI also they taught, na? The beam search and the
Yes,
did.
yes, same.
Okay.
So I think what we will try to do, we will try to find out these technical things here, wherever the code, because we have seen in quiz 1, they have asked a lot of questions on that. So let's see that collab which is running. This is still running. It will have 600, so it will take a lot of time. So let's see this code, how this is working. So what we have done, we have transcribed the audio in parts, in the segments, and then we are doing from this segments and the transcription which we have got. Now we will try to extract the segment embeddings, and for this, we are using Lebrosa. So Lebrosa is basically used to load the audio and create segment. So we have loaded audio and SR, librosa.load audio file, sample rate is 16,000, mono is equal to true, then start and end, segment start and segment end, which we are getting from here. And then we get start and min start total duration and min end total duration. Then we get the waveform. So this audio which we have taken from the audio file, it will start from the start into sampling rate to int of end into sampling rate. So we get the waveform, then we convert this waveform into tensor. Data type is float 32. And then we use the embedding model to get the embeddings of this and in the batches, and it will return embedding. Then we define a compute segment embeddings. So again, we are using the Librosa passing, we are passing total duration, and then we are getting embeddings, and we are using this function which we are defined on top, extract segment embedding, and we are passing, and then we are getting the embeddings and total duration. And now these embeddings we have got now for the segments, now we will use any clustering model to cluster them. So for example, here we have used the k-means. So k-means will fit into the embeddings, and then it will find the cluster averages also. Then we have got to define to load the known speaker embeddings to test it. For example, if we know, so known speaker embeddings, initially it is a dictionary blank, and then for speaker ID file path in known speaker files names Y and SR, again we are loading from Librosa. Then we are getting audio tensor from this Y is okay, from the file path we are getting audio tensor from the unsqueezed 0 from audio tensor, and again we are getting the embeddings of this using the embedding model. And then we are updating this known speaker embeddings with the speaker ID. So we have got the speaker ID, and it will pass the embedding to that. So this will help us to club those clusters with the same speakers. Second is to assign the speaker labels. So we have got cluster average embeddings, known speaker embeddings, and similarity threshold. We are putting 0.7. So initial, again, a blank dictionary, best scores is blank dictionary. We are passing cluster, getting cluster ID, average embeddings in the cluster, average embeddings dot items. Max similarity is 0, assign speaker is unknown. So now for speaker, known embedding in the known speaker embeddings, which we have got in the previous function, we define the similarity, which is a cosine similarity between average embedding we are reshaping and the known embedding reshape. So if this is the similarity of those embeddings, so if the similarity is more than max similarity, then max similarity becomes similarity, and as we assign the speaker to that, and we pass it, so it's a function, and then we are making a pipeline of all the functions which we have written. So first we are doing the transcribe with the function we have written. Then we are getting the embedding and duration from this function already defined. Third, we are getting labels and centroids by cluster embedding function. Then cluster average embeddings by using compute cluster averages function, and speaker labels best scores by assigning speaker labels. And then we are formatting the output. And then we are passing it and making a data frame. So we get the total duration, df minus df start second sum, and we return the data frame, length of the segment, centroids, best scores, and total durations. So with these functions, now we come to the data. So this data has been downloaded, and this was one question on the WhatsApp somebody had written, that what is the there is a function now in Linux to convert an audio format to a different audio format. So if we have got a web and we have to convert to MP3 with the sampling rate, so we pass first the input, then we pass the sampling rate, and then we pass the output. And here we are defining the embedding model, and now from this we are getting the known speaker embeddings by that function which we have defined. Then we are processing the clean audio sample. Clean audio is sample, and we are running that pipeline to get all the data. And similarly, we are doing for the noisy one also, and we get both DF clean and DF noisy. If I'm not wrong, Vivek, this is the GA part, na? In the GA, we have done
Yes,
this.
yeah.
Hello?
Yes, sir.
Okay. So in this, okay, what are the main takeaways, Dinkar? Can you summarize what we are doing?
Yes, sir. So basically, first what we are doing, we are loading the data set. Okay, that is the first step. Then we are converting it into .wav file if it is not in .wav file, and we are converting it into 16,000 sampling rates.
Yeah.
After doing that, we are trying, we are converting, defining a function for converting things into second, and then we are trying to extract the speech.
Okay. So
And
what
once
we are
we
doing?
extract,
Uh,
we have just into a data frame. Then we are applying a model to check the cosine similarity, or there is one more equilibrium distance.
okay, waveform embeddings. Is this correct again? We are getting this waveform embeddings segment wise,
Correct.
segment
Yes.
wise. Okay, and then what we are doing, this waveform embeddings which are there, then from all the data, we are getting the speaker ID
Correct.
by similarity one, and we are using cosine similarity.
Yes.
And then what we do, we are using now, we have got clusters here. Now we have got embeddings. So different embeddings which are there. And now we are clustering them using the k-means. So we get the clusters. Now, and with the speaker label. Is that correct, Akar?
Sir, I have a doubt.
Yeah,
In this code that you shown, you have used Librosa
yeah.
to convert the audio file into embeddings.
No. Librosa has not been used for the embedding part. Librosa is used for loading the audio file.
Loading.
Yeah, I'll just show you the code also. For
Okay.
embedding, okay, embedding model has been used.
Ah, yes, embedding. Can you
For
check what was the use of Librosa?
Librosa is for the loading. I'll show you. Okay, just come here on top. So we get starting from here. See, audio SR is equal to librosa dot load. Okay,
Okay.
so you
So
are
what will this audio have? Means this audio will be a means an
so
array.
see this audio file we had seen earlier in this. So audio file format is like this.
Okay.
We had seen that. So this is like a audio file.
Right.
So this has got audio ID, language, and this is the main part, audio, which
Okay.
contains this. This has got three parts: path, array, and sampling rate. And when we do the embedding, we are doing the embedding of
Mm-hmm.
this one.
I'm not
Okay.
sure, but I think if you check up this Librosa, I think may converts it into a NumPy array, and it
Yes,
is
yes,
helpful in calculation.
yes,
So it
yes,
helps in calculation.
yes. Okay, so they see when Librosa is loading audio file and it is getting audio and it is getting this SR. SR is sampling rate, and it is already using, we are passing 16,000. And for
Mm-hmm.
the embedding part, we are using the embedding model. Okay.
So means just to clarify, what is the difference between using Librosa and embedding model?
See, Librosa is loading your audio file, and whatever you want to extract from that audio file, you are extracting that. So it is not doing any embedding on that.
Okay. Okay.
Okay. Embedding you are doing by this embedding model, and embedding model I'll just show you where we have defined. Where when you have come here, see, this is the embedding model.
Okay. Okay.
So you have done embedding model from speaker recognition, from H params, and from speech brain. So for this, you are using this Vox cell speech brain का. ठीक है?
Okay.
So
हाँ.
in this क्या जो week 6 है, इसमें हमारा क्या है बेसिकली वी आर हमें ऑडियो दिए हैं बहुत सारे ऑडियो, उसमें से पहले हमने ऑडियो निकाला, सैम्पलिंग रेट हमने निकाला, फिर हमने उसमें जो स्पीकर आईडीज हैं, स्पीकर आईडीज क्या कैसे निकालेंगे, पहले हमने इसको एम्बेडिंग किया सभी को सेगमेंट वाइज, तो डिफरेंट डिफरेंट 16,000 रेट में एवरी 16,000 दिस वी हैव गॉट द एम्बेडिंग्स, we have got the embeddings. Okay, now what we do, we do the cluster here. So whichever embeddings they are closer, so these embeddings will form one cluster, These embeddings will form one cluster. These embeddings will form one cluster. So now by knowing this cluster, we will come to know that this is, for example, now we give the labels to them, that this is speaker 1, this is speaker 2, this is speaker 3. Okay. And just we can check a whisper model also, what whisper model is doing in this. And we have used a whisper model also here somewhere.
Yes,
Yes.
sir.
Okay, so we can check where we are using the whisper model. So let's see.
We are using it in speech to text conversion.
Speech to text. Okay, so but
Yes.
in this though there is no speech to text in week 6.
No, there
Yes,
is.
it is not required. Uh,
And week 6 mein it is not
yes.
required.
Yes. Only classification was required.
But in the collab, it is there, sir.
Okay, just
Yes, it is used. It is
let's
used.
let's see where it
Means
is
how
used.
without converting the audio to text, how you are going to assign it, what was
Okay,
said and who said.
okay. So this is is passing in the pipeline. Okay, in the pipeline when we have made. So here it is passing transcribe audio. Okay, and transcribe audio was our first function. Okay, so here we are using, so what it is doing, model name, compute type, model transcribe, audio file beam size, and it is transcribing start segment and segment in segments.
So
Yes,
whisper
this,
model is used to create segments.
yes, yes.
Okay,
Okay.
okay,
These
It
segments are
automatically creates segments like start,
th-
end, and the text.
okay. These segments are later converted into embeddings
yes,
using that speech brain model,
yes,
and then those embeddings are used in the agglomerative clustering.
yes.
Speaker
Okay.
ID embeddings, yeah. Speaker embeddings, yes.
Okay.
Okay, so जो मेन है वो तो हमें आ गया समझ में. Vivek, can you explain please week 7 please?
I'm very bad at this.
No, no,
You are the
we will
master.
just go through the code, okay, just try to back out.
Okay.
Otherwise, okay, only the questions will come like this only. So
Yeah.
if we have understood, okay, so मेरी जो understanding I will just okay, tell you. My
Okay.
understanding I will just explain okay here. कि जितनी भी हमारी अंडरस्टैंडिंग है अभी कि हमारे जितने भी मॉडल्स होते हैं जैसे वेव टू वैक मॉडल है so it has got okay, all the parts, so it has got a feature extractor also, it has got a tokenizer also, and if I directly take the web to web processor, then this processor has got both the parts. It
Right.
gets feature and extractor also, and it has got a tokenizer also. So when we are getting the speech, for example, this is a speech which has come, so it is in the array format. Okay, when you take care, so in the week 5 was the identification of the speech. So how we were doing this? Okay, we were getting the feature extracted at every 16,000 sample rate. So we got embeddings or the feature extract features for the audio, and then we also took the label. So label was the language, for example, Tamil, and this was a feature as a tensor. So we got all the features one by one and along with the labels. So now when you train this on a CNN model, it is will give you cross entropy loss because we are passing all these okay, features, and then we are identifying with the label whether it is the same or not. If it is not, it is passing the loss okay, backward, and your model has got trained. So now if you pass any audio after extracting the features with the same with which we had done for this, and you pass a new audio after feature extracted to this CNN model. So now it will give me a label. It will tell me whether it is Tamil or Romanian or Telugu on which I had trained. Is this understanding correct? Okay?
Yes.
Anyone?
Yes. Absolutely.
है ना?
This is
And
what
फिर
I have understood also. That this is
yeah,
what it.
and फिर जो week 6 मेरे जो अभी तक समझ में आया, that week 6 में we do the diarization. So diarization में what we try to do, that we have got a long audio in which we have got number of speakers, and we want to know that which audio part has been spoken by which speaker. So in that first part is we have to make the segments which we are doing by using fast whisper, and we are loading the audio using librosa for loading the data, for loading this audio file. And we also pass sampling rate in this, and whatever we want to extract, okay, we write okay here. For example, we want to take the audio file or that, and so, and this is making the segments. So once we have got this segments, now we do the embeddings of these segments. So we get the embeddings of this segment, and now with this embeddings, whatever embeddings we have got, so we have got two parts. First of all, part is to make the clusters or number. Before that, what we can do, by using the cosine similarity, we can come to know that which all clusters are close to each other, whichever, sorry, this embeddings are close to each other. So we get this embedding close to this. So I know that this has come from one speaker, this has come from another, and then I either use k-means or any other clustering format to get this. Is this okay? Understanding correct? Okay, anyone?
Yes, sir.
Okay. So week 7, I will request somebody else to take on, please. This I will just release my screen. Shubham.
सर मैंने तो नहीं किया वीक 7 अभी। मैं तो आपके सेशन से समझने आया हूँ।
ओके ओके, सो चलो मैं ये केस को करता हूँ, वीक 7 को मैं लोड करता हूँ, देन विल सी, है ना, जो भी
ओके
जितना भी समझ में आता है ना. ओके सो ओके सो हियर आई हैव गॉट वीक 5, वीक 6, वीक 7 भी मेरे कॉलम में था. आई जस्ट ओपन दैट. ज्यादा ही डाटा इसमें डाल दिया. So week 6 we have done. I will try to open notebook. Yes. Has anybody done the PYQ of this again? And week 7, if I'm not wrong, it was speech to, it was text to speech or speech to text? It was speech to text.
Speech to text. Yeah.
Speech to text. Huh? So let's see this code. Okay, I will open from here. So it is already there. Yeah. So in this, what we have done in the speech to text, we have used the same. So see here in this, first we are loading the data set. So it is a ASR data set, and then we are extracting all the characters. So it is not word wise. It is we have made a first of all list, and then we are passing getting a vocab which contains all the text. And then vocabs we are passing using the map function, extract all characters, and in a batch size of 8, so we are getting the vocabs. And then from vocab list, then we are making a vocab list we get, and then we are building a vocab dictionary. So the first function is for the week 7 is week 7 build vocab dictionary dict. Okay, and first you extract all characters. Okay, and then using this, so we have got the vocab dict. So then we add unknown and pad also to the vocab dict, and then we dump it as a vocab JSON. So we have dumped it. इतना समझ में आया सभी के, ये वाला हिस्सा जो
Yes, sir.
है ना? Okay.
Mhm.
Now what we do, now we are initializing a tokenizer. So again we are using a web to back to CTC tokenizer. So here this comes like a CTC part. So we are also passing unknown token and pad and word delimiter token. So we had converted all the spaces to this horizontal this. So after tokenizer, now we are extracting the tokens of, we are defining a feature extractor. So we are doing web to web feature extractor. If we use web to web processor, then the same one can be used as a tokenizer also and a feature extractor also. And now what we define, now we are taking a processor separately. So we have got tokenizer, we have got feature extractor, and we have got a processor. And then we are passing just printing dataset train 56 text. What is the text in this? And then array shape dataset train audio array shape we are checking. So shape comes, and then we are checking the sampling rate, which is in the audio sampling rate. So sampling rate is 16,000, and input array shape is 76,624. So these are the values in one array. Now we prepare the data set. So this is very, very similar what we had done in our NPP too. If all of you remember, we had done this same step to prepare the data step. So using the processor, we have got the input values from the array, and then we have got the input length, which is the length of batch of this. And then processor as target processor, we have also extracted the labels. And labels we have taken from where? We have taken from text input IDs. After preparing the data set, so we have prepared this data set, we have got array का full feature extract होकर आ गए हमारे पास में, and हमारे पास label आ गए. So we have got two parts again now. So second part is that now we have prepared data set which has got features. Yeah. Hi Sima. Ask. Okay. 5A. Okay, just give me a second. I'll be back. Okay, I'm back. Hi, am I audible?
Yes, sir.
Okay. So what we have done, now we have prepared the data set. We have got the input values by using this processor, and we have got input length and the labels. So our input will be modeled, will be input values, input length. These are for the features, and then we have got the labels. So these are the two things we are passing. And if I'm not wrong, then now we will prepare the data, collate the data. So this is the same function again we have used in NPP2. We define the processor, we define the padding, and we call a call function. We pass the input features, label features, and this is for batch processing. And with self processor is target processor, we are defining label batches, and we are padding the labels also. So we have prepared again now labels, and batch labels is equal to labels. So this is, and in fact, okay, this function we don't require. We even can use data collator directly. So we can, this is a data collator CTC with padding. Processor is equal to processor, and we have defined this function. And here what we used, we are using, we have to import here this one. I'll just tell you. Data collator. We have defined our own. Otherwise, Web2Vec has got its own data collator also. We can use that directly. And then this WER matrix. So WER matrix is very easy. So the difference between CTC matrix and WER matrix is different. So CTC loss is basically used when there is alignment is not there. So you got speeches, text, and they are not aligned. And WER loss is that the total number of words which are there. So this is total number of words. You calculate total number of substitutions that which are incorrect, then total number of insertions and total number of deletions, and you divide it by total number. So then you get this WER loss. So this, so we have to remember that for speech to text, we use WER loss. WER loss. Okay, now we have defined, so now we define the compute matrix, and in the compute matrix, we use this WER only. So WER is WER metric, compute from the prediction and the reference. We prepared the data, we split the data for evaluating. We then define the model, which is auto model for CTC, and from the VAC to VAC only. And while training, we freeze the feature encoder. So what is the meaning of this feature freeze feature encoder? It means that whatever the model you are using, so this model has got its own weights inside, and it has got, so it is a, and it has got one head. So while training, it will train only its head, and it will not update, okay, these weights. So that's the meaning of freezing this. And then we train, make the training arguments, batch size, per device eval size, what are the different metric points are there, and then we define the trainer, and then we train. So this, I think it is straightforward, okay, like all of us, we have done NPP2. So the steps are quite clear. Any doubt, okay, in anybody's mind in this? Anyone? So shall I explain the basic steps of week 7? Am I audible?
Yeah, yeah.
Yes, yes.
Okay.
Yes.
So what we did, okay, we have made, okay, first, okay, vocab dict. So it is like the vocab size we have done. Then we have got used, okay, tokenizer. We have used feature extractor, and but in the code I have not seen the use of this. So tokenizer and feature extractor, tokenizer will build the tokens from the vocab dict, okay, because it is like a vocab we have got. And then we have prepared the data set, and here we have used the processor on the array, with the sampling rate and then with the padding. And this
I think I think that processor we've wrapped the tokenizer and feature extractor.
but here what they did, Vivek, they
Hmm.
have called this processor separately. They have imported. I'll just show you. So see, they imported this as a okay. So Web2 processor, and they have passed this feature extractor and tokenizer. Okay,
Right.
you're right. Okay, and then we have prepared this data set, and this data set, okay, when we have prepared, so it will return input values and input length. These are tensors, and they will also pass okay, labels. So this we have got okay now. And third, okay, fourth part is now we do the data collation,
Calculator. Right.
data collator, and then we do model. We define a model, initialize model, and then we freeze the model parameters, freeze. Then we make the
One step
training.
was define the metric.
Yes, yeah. So here, okay, we define the W compute matrix, compute metric, and we use WER. Then we make training arguments. Then we make trainer, and then we do the trainer.train. So effectively, what is happening that we have got a case speech and we have got text. Now this speech part which is there, we have extracted the features now using this processor, which has got tokenizer and which has got the feature extractor. So with every 16,000 sampling rate we have taken, so it has extracted those features, and now we are passing to this model. So this is a model, and here I have got labels. So labels is nothing but okay, this text okay, which is there. So this text okay, is there. I pass okay, this, and then I correlate what is matching and what is not matching. And in this, it will happen character wise. Am I right, okay? In this, so any loss which is there, it will update. It will find okay, the WER. It will check substitution, deletion, insertion, and then it will update okay, its final layer wala weights during the training. And now in the last, you will pass your test, which you had used to get trained test spread. And now you try to make out how many you have correctly produced the same text. This is the framework. Anyone, any additional in this? Dinkar?
No, sir.
Okay. Okay. So I think week 7, okay, I think we are quite clear what is happening in week 7. So can we open week 8 now?
Yes.
Okay. Okay, so week 8 is TTS, text to speech. So again, we are using the same sound file speech brain. And here we use something called, okay, this is normal load. We have data set, and then data set we have taken from data sets, we have imported audio. So this is one audio. This, what is the meaning of this? Okay, anybody can tell me?
So
Cast
the
call.
downcasting the sampling rate to 16,000 hertz.
Okay.
So it was actually, I think the data is of 48,000.
Okay. Then rate to 16,000. Okay. So data set cast column, it will convert to sampling rate to 16,000, and it is using this
Audio library.
audio which we have imported. Now we import speech T5 processor. So speech T5, and we also define this checkpoint, that from which checkpoint we want to use. And then we build the speech, this T5 processor from pre-trained from this checkpoint. And tokenizer is the processor tokenizer. Then we see the data set. It is the same format which we have been seeing. Audio ID language, audio, which has got these three parts. Then we have got raw text, normalized text, gender, speaker ID, and all that. Now again, we are doing the same extract all characters, and then we are building vocabs. So after extracting all characters, we do build the vocabs. And so dataset vocab is the set of vocab which we get, and tokenizer we build again. So from here we get the tokenizer vocab. So here we saw that when we print this tokenizer vocab minus dataset vocab minus tokenizer vocab, so we get the differences in that. And these are the, now we have to map them to their original this. So this professor had explained. So we use this function cleanup. So we do replacing by this replacement, and now we have done the cleaned up the text. Okay, now data sets has got speech from multiple speakers, but how many speakers are represented in the data set? So for that, we have to count the number of unique speakers. So in that, what we are using default dict, and we are making speaker counts as a default dict, and then speaker ID in data set speaker ID. So here speaker ID is there when we see the data set. So here is the speaker ID. So this, okay, we are fetching from here, and then we can, by using the unique, now we know, or by using value counts, we can find out how many speakers are there. So this is there. So from here we get the speaker ID, and we can see, use the matplotlib pyplot to see the different speakers. Okay, and now we are selecting speaker as per their value counts, that if their count is more than 100 and less than 400. So we are select only those speakers. And then we are using filter. And in filter and in map, first of all, we have to find pass a function. So first you define a function and then pass it in the map or filter. And we are passing on data set on the input column, speaker ID. So this will give. Now after this, we have got data set speaker ID. We have got 14 unique speaker IDs. Length of data set is this much. And now this is the function which is we are importing encoder classifier from SpeechBrain. Model is this one, model 1. Device is okay. Now speaker model is encoder classifier, and we are passing this speaker model in this, and we are saving this in our directory in temp speaker model name. And now we are defining speaker embeddings of the waveform. So speaker embedding is, then we are passing this speaker model. It will encode batch waveform. So we will see niche ki what is this waveform. So we got speaker embeddings first from here waveform. Then we normalize it by using torch-nn functional normalize, and we get by squeezing as numpy array as the speaker embeddings, and it returns speaker embeddings. So we see what is this, and then prepare data set, it remains the same what we had used earlier. So it is returning this prepare data set. Only here we can see something, that speaker embedding it is getting from that function which we had passed, and this waveform, I was correct, I was assuming that it will be audio array. So from this array it has extracted the speaker embeddings. And in example, what it is getting text from normalized text. Okay, from that audio target is equal to audio array. This is the target because it is text to speech. So we are passing text, and we will compare it with the speech with this array. Sampling rate is the same sampling rate, and return attention mask is false, because it is a basically in week 8 what we understand, it works like a BERT model. We are masking something and we are trying to predict it. We are passing the labels, so we have got it. Now we prepare the data set. We have done, and again we get input IDs, labels, and speaker embeddings. And we can see with this, and now we have done that passed this function to the entire data set. We have also found defined is not too long, that if the length is less than 200, then it will be this. So we are passing only, we are filtering by the size of 200. So input length will be less than 200, it will get. We pass this prepare on this, we make the train test, then we make the data collect collator, same one, only your input and output will be different. We prepare the data collator. We now this is the model which we are using. So model is speech T5 for text to speech from pre-trained. Checkpoint remains the same, and this is for using cache or not. And then we use training arguments. We make the trainer, which will be a sequence to sequence trainer. So this is a difference in this. So here sequence to sequence, and then we train. So can anybody can summarize this? Okay, what are the main parts of this code? Anyone? Text to speech. Try to remember what all we have done. We have done first. Okay, we have built the vocab.
Vocab, right.
Okay. Then we have used the tokenizer to
Compared the two.
tokenize this vocab. And then it is like we are passing text and we are trying to get the speech. So here, what we will do, we will like tokenize this text also.
So we've tokenized the original text, and with the vocab, we've seen the difference if they're coming in the letters.
Yes, yes.
So that we have replaced.
Yes. So it is the model tokenizer, model का जो data set full जो वो है, and minus tokenizer का जो है, और उसको फिर हमने clean किया, है ना?
Right.
This. Then this is one part we have done. So this we have done for the text part. Now we come that whatever the audio we are getting, now we are preparing the data set. So in the data set, what do we need? We need after that, what we did, we extracted all the speaker IDs.
Speaker IDs.
Okay, and speaker IDs also we by length we try to correlate. So we got speaker IDs, and now we prepared the data set. So while preparing the data set, what we have done, we have text का जो है वो हमने tokenizer निकाल दिया, tokenizer use किया. So we get the input values. Then we get the input length. And जो speaker ID की जो embeddings थी, जो speaker IDs की, we got the speaker embeddings. So this is our input, this is our output. So we are passing this, and now we are correlating with this. Embedding जो है वो हम waveform की निकाल रहे हैं, audio array की. So this we get, and now using this model, which is a sequence to sequence classifier, we pass it to the model, and depending on the loss, we are updating the parameters. Is this okay?
Yes.
And can we see the loss again? What loss they are using? Because earlier we had used the WER loss. So here they have not defined any compute metric. यहाँ पर देखते हैं, यहाँ पे जनरली आता है
ट्रेनिंग उस पे आएगा नेक्स्ट वाले पे.
हाँ, ट्रेनिंग आर्गुमेंट्स के पहले जनरली भी डिफाइन करते हैं.
वो ट्रेनर पे आएगा ना कंप्यूट मैट्रिक्स.
हाँ, इधर इसमें इन्होंने लिया नहीं है.
नहीं है. हाँ.
नहीं है. तो इसमें नॉर्मल वो है, ट्रेन किया है. पुश टू हब है, ये तो लास्ट है. इन्फ्रेंस इज डिफरेंट. इन्फ्रेंस में आप एक टेक्स्ट पास करेंगे और फिर क्या इसको लोड किया है अपने हब से, and then you pass some text, okay, for example this one, and it will generate. So if I'm not wrong, ये आपका loss will be something WER हम इस पे ले नहीं रहे हैं, something it will be like a cross entropy loss kind of thing. Loss they have not defined because we are passing some tokens. यहाँ पे हमने टोकन पास किए विद इनपुट वैल्यू, और यहाँ पे हमें वो एम्बेडिंग्स हैं, ये अपना मॉडल है. सो अगर ये इससे कोरिलेट नहीं कर रहे, सो इट विल डू द क्रॉस एंट्रोपी लॉस ओनली. I will try to find this. Okay, I will post in the WhatsApp group. है ना? What is the loss? Okay, in the TTS model. What is the loss function? Okay, I will try. Okay. So with this, okay, whatever I could understand, I have explained. Anybody wants to add like anything new or wants to ask anything?